Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here at the Boys and Girls Club here in Bakersfield, and we're here to do the
M-A-T-H!
Do the Math! Yeah!
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Chloe. And Chloe, if somebody needed to get a hold of us, what would they need to do?
For math homework, help, call in Bakersfield 636-4357. Toll free 1-866-366284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. A lot of ways to get a hold of us, huh? Why don't you let everybody know where you go to school and what grade you're in?
I go to Quellwood, and I'm in 5th grade.
How's 5th grade going?
Good?
You been at Quellwood for a long time?
Yes.
You're Cougars, correct? Mm-hmm. All right. What is the best thing about 5th grade right now? What do you really like about 5th grade?
My teacher.
Oh, that's,
good
you're in there all
answer.
day with
Good
that teacher,
answer.
right? All right. So that's good. Have you had that teacher before, or this is your first year with them?
First year.
This is your first year? All right. Well, you think you'll miss that person next year?
Yeah.
Probably, if you like your teacher a lot, right? Well, you know what? You'll be able to see them because you'll be at Quellwood again next year, right? Mm-hmm. Do you have any idea why you're here today?
Because I wanted to do the math.
That's right. You wanted to do the math, so let's have you do the math, all right? You ready? All right, head on over to the board quickly. Now, you said that you're in class right now working on conversions and working with the metric system a little bit. So what I'd like you to do is work with Devin a little bit and just tell Devin kind of some basics that you know about the metric system right now. And then Devin will kind of work with a meter, centimeter, things like that, kind of quickly just to make sure that we're all on the same page.
Let's
All
talk
right.
metric. What do we know?
Kilo, hecto, deca.
Let's write some of these down, because I think what's interesting about the metric system is regardless of what we're measuring, these terms mean something. So you mentioned some terms. You mentioned kilo. What was the next one?
Hecto,
Okay. All right. What else?
deca,
Okay.
and then the base of the middle.
Okay. We'll just write a base right over here, because that's going to be whatever the unit is, right? Okay. Are there others?
Deci,
Okay. So deca, or I'm sorry, deca would be like with a K, right?
Yeah.
And then we have deci. Okay. Are there any others?
deci, centi,
Okay.
milli.
Okay. Now, what's interesting about the metric system, you're right, is that we do have these terms. Do you know what language these originally come from, generally? They're really important, especially when you get to 5th, 6th grade as far as making meanings of words. These actually all come from ancient Greek. The Greeks were some of the first people to use standardized measurements. And the way that they did that was they found one common length or weight or other type of unit, and they multiplied that by certain values. So let's say, for example, we were talking about length. For length, we use meters in the metric system. In fact, that's where we get the word metric from. Meter, metric. So we have 1 meter. But what's great about these is you can use these to represent how long each of these are in relation to a standard meter. So a meter is, generally about, this long. It's comparable to what we see in like a yard, about 3 feet. Not so much though. There is a little difference. So how would each of these terms relate to meters? So for example, centimeter. All right, I'll bring back milli in a little bit, but I want to talk just about centimeters here, all right? How many centimeters are in 1 meter? If we don't know, we can go to the root word itself. So what does centi mean? Or is there a part of centi that we recognize?
Cent.
So that's interesting. You said the word cent. When you think of the word cent, what does it make you think of?
1.
So when you think of 1 cent, right? You're thinking like a penny, okay? How many cents, how many pennies are in a dollar?
100.
100, right? When we think of cents, we think of 1/100th of a dollar, right? Let me know if you're familiar with this term. Century. Do you know what a century is?
100.
100 what? 100 years, right. So a year is 1/100th of a century. So let's think about a centimeter. If a cent is 1/100th of a dollar, and a year is 1/100th of a century, what do you think a centimeter is?
100.
1/100th of a meter. So, there are 100 centimeters in 1 meter. We know that deci can mean some things too, right? When we think of deci, what does this make you think of? Or where do you see something similar to deci?
I don't know.
Well, you said that you were exploring decimals, right? Mm-hmm. So let me put it to you this way. We think of decimals, right? Let's say I represent this decimal. How would I say this decimal without saying 0.1?
0 and 1/10.
1/10. So a decimal, this first place, is 1/10 of a whole. Here's another year term, which is similar to deci.
A decade is 10.
10. 10 what?
10 years.
So a year is 1/10 of a decade. So how many, I'm going to go ahead and move this word over now here. How many decimeters are in 1 meter?
10.
10. So a decimeter is 1/10 of a meter. And by the way, this works out with any other unit too. Liters, grams, all of these have a meaning as far as what they represent. Milli would be 1,000. So a millimeter is 1,000th of a meter. But then you go higher and this represents another scale. A decameter would be 10 meters. A hectameter would be 100 meters, and a kilometer or a kilometer would be 1,000 exactly. And so as you explore each of these terms, you realize that there's a multiple of 10 for each of them.
There you go. Nicely done. A great base for working with the rest of the metric system
Thanks,
that
Greeks.
Chloe is working on in 5th grade right now. All right. 636-4357 is the phone number. We do have phone tutors available until 5:30 as we most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. So we're going to tie this into math. You'll see how, even though it doesn't directly go to it. But that's the beauty of this. We can always take a meandering way to get there. On March 30th, 1870, Hamilton Fish the United States Secretary of State certified the 15th Amendment of the Constitution as ratified. So, the amendment states, in relevant part, that the right of citizens of the United States to vote shall not be denied on account of race, color, or previous condition of servitude. In short, it made it so that African American males would be able to vote. All right? This is what they would do, though. They would have literacy tests for people, and we have one of the literacy tests from 1964 from Louisiana.
So this was a practice that continued almost
Until
100 years.
1964.
Wow.
All right? So, yeah, until 1964, this was commonplace. So, Chloe, we're going to have you kind of help us out a little bit with these, all right? So you can see it up on the bottom monitor right there and a little bigger right there. So we're going to look at the ones that I circled, okay? In the first circle below, write the last letter of the first word beginning with L. So in the first circle below, what do you think they're talking about right there, Chloe?
The one.
The one, right? Write the last letter of the first word beginning with L. So what word do you think they're referring to? What word begins with L? So do you see any words in that sentence that begin with the letter L?
No.
Let's
Then
go
you can't
through
vote. I'm sorry, Chloe. This was your opportunity.
it. In
Isn't
the
that
first
awful?
circle below, right? None of those begin with L, right? Okay.
So they're talking about the sentence itself.
The sentence itself,
Oof.
right? Now, keep in mind, you have 10 minutes and there are 30 questions. And if you get one wrong, you don't vote. Okay? So, what about last? You see last up there?
Yeah.
Now, is that the first word that has an L in it?
Yeah.
Okay, so that's the one we're going to be looking at. So let's look at the question again. It says, in the first circle below, you said circle 1, write the last letter of the first word beginning with L. So what letter would go in that number circle? Because we're going to look at last, right? Mm-hmm. That's the word we're looking at. And what's the last letter of that word?
The L.
Well, the L is the first letter. What's the last letter of it? The word last.
T.
T. There you go, right? So you would put the letter T in that first circle. Make sense? Mm-hmm. After you read it a couple times, right, to make sure what they're asking for, all right? The next one, number 13, in the line below, so you see all the numbers 31, 16, 48, 29? Mm-hmm. All right. We're going to cross out every number that is more than 20 and less than 30. So would 31 get crossed out?
No.
No. What about 16?
No.
No. 48?
No.
No, because we're looking for more than 20 and less than 30, so it's 21 to 29, right? What about the next one, 29?
29.
Yeah, we'd cross that out, right? Mm-hmm. Okay. What about 53?
No.
No. 47?
40. No.
No. 22?
Yes.
Yeah. 37?
No.
No. 98?
No.
26?
Yes.
Yes. What about 20? Because it has to be more than 20. So would we cross out 20?
No.
No. And what about 25?
Yes.
Yes. Okay. So there are a few more, and these are just ones that have to do with math that I pointed out.
Which, if you go and expecting
So we
a
can
literacy
see
test,
a few more.
right?
So these are, okay, here's a good one. Spell backwards forwards. Now, if it says spelled backwards forwards, you're going to spell backwards B-A-C-K-W-A-R-D-S. But some people could look at that differently and get all messed up. And remember, if you get one wrong, you're done. Now, what I'd like you to do is, do you see the triangle? What does it say in the triangle? Can you read that from here?
Yeah.
What does it say?
Paris in the spring.
Paris in the spring.
The spring.
There we go.
So what is it?
Paris in the spring.
Right. See, now a lot of people, the first time, they would say Paris in the spring. looking
Right.
at it quickly, right? Because remember, this is a time test. You have 10 minutes to do 30 of these problems. Everybody that I ever asked always said Paris in the spring. However, the key to that is to maybe take your time and you want to write it down. So if you write it down without looking at it again, and then here's another thing, look at it going backwards. Spring the in Paris. Now you know something's really odd, right? But anyway, that's how we get to today's math in the news, because today there are primaries going on.
That's right.
Talking about voting, so I figured, you know what, let's do a little math in the news about voting. When that amendment was ratified and kind of what they did to kind of keep people still out of it a little bit right
Yeah.
there.
Would you say that that's a fair practice to let people to vote, or do you think that was unfair to a lot of people?
It was unfair to a lot of people.
I think so. I think
Right.
a lot more than I think we realize.
There you go. All right, 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. And we do have an opportunity right now. We're going to go out and see what the kids are doing at the Boys and Girls Clubs.
We are here at the Bakersfield Boys and Girls Club, and we are ready to do some math today. Everyone's got their uniform on, their Boys and Girls Club uniform on today. We're gonna do some geometry, and I know that that word kind of scares some people, but I'm gonna see if I can do my best to unscare you. Are you ready? Here we go. I'm gonna give each of you this wonderful blue circle, and you can't make fun of me for cutting it out poorly, because I'm a really good teacher, but not so good at cutting out circles, okay? But the round part is not the part that's important about this circle, all right? Do you know how many degrees are in a circle?
360?
That's it. That's exactly right. So if you're skateboarding this way, right, and you all the way around again and go that way, you did a 360. You've heard that before, right? So it makes sense. So somewhere on your paper there, somewhere on your circle, write down 360 with a little tiny circle or a little tiny zero at the top to make a degree sign, right? 360. So if you ever have it wide open, you'll know this 360. Now, can you make a taco? Of course you can. Fold it right in half. Now again, we are not worried about the round part here, okay? We are worried about the flat part. So you see this flat part at the bottom, okay? If we had 360 and we just cut it in half like a taco, what is the measure of this angle right here that's a flat angle right here, or a straight angle? What's half of 360? What is it?
180.
180, yeah. If I'm skateboarding this way, and I turn around now I'm skateboarding this way, I just did me a 180, right? So somewhere on there, I want you to write down 180. 180 degrees. So we're learning some geometry, and you can even take this home with you. This is going to be your protractor, okay? Or compass. Protractor, I guess. Ready? Take your taco, fold it in half. You got it. You know what's coming. That's it. I like it. You know what's coming. So now, again, please don't worry about the round part, okay? Or the not so round part. Thank you very much. Look at just the straight part, okay? So now we're looking at going down and going straight over. How big is this angle right here?
90.
90, that's it, see? I'm telling you, you guys know geometry even though you didn't even know you knew geometry. So this is a 90-degree angle. In fact, it is a perfect 90-degree angle. It might even be better than one of those protractors that you buy at the store because you have created it and you know it's exactly the right angle. So somewhere on there, please write down 90. We're gonna do it one more time? I think that's a great idea. Let's do that. Ready? Fold carefully, but take your 90 and fold it one more time to make yourself an ice cream cone. You gotta make sure that when you fold this one, that you really make it come to a point, okay? So this is like a piece of pie or a piece of pizza, right? Or whatever you're gonna call it there. There you go, that's it. Make it come to a point, okay? Yep, that's it. And just fold it right on the edge there. And so it still comes to a point. If you could balance it, that'd be cool, right? But that's your next one. So we did 360, cut it in half, 180. Cut it in half, 90. Cut it in half, and we have
45.
Oh, man, smart people. I like it. Man, you must have a really good teacher, at least today.
No.
All right, 45. Put 45 on there somewhere, okay? And what you're going to do now is you are going to, somewhere on your paper, draw a 45-degree angle. And here's how you do it. You have the tool right in front of you, okay? And all I need you to do when you draw this angle is put it down right there on the paper and just trace the straight sides. Just the straight sides, not the round part. Anywhere on your paper. Got it? Violet's got it. Just like that. And right in the middle of your alligator there, okay, right in the middle of there, Brandon, write down 45. You have just drawn an exact 45-degree angle. That's it, Kalia, right? 45, right in the middle there, okay? And remember, you don't have to worry about the round part. You don't have to erase it. It's okay to have it there. But when we're drawing our angles from now on, you only have to worry about the straight part, okay? So right in the middle there somewhere, write down 45. You have drawn a 45-degree angle. Nice job. Somewhere next to that, above it, below it, on the side of it, somewhere, I want you to take your 45-degree angle and open it up, please. Okay? So now you can see you have 45 and 45, right? And what do you have?
90.
A 90. So somewhere on your paper, please, draw a 90-degree angle, okay? And just open it up to two of those 45s and draw one side and draw the other, and you'll have an exact 90-degree angle. And you can draw a 90 right in the middle there. Harry, what do you got? Just like that, yeah? Just draw just the straight side, that's right. Don't worry about the round part at all. Because when you look at angles, right, the angle of a window, angle of a door, angle of this table, right, angle of the corner of this paper, there's no round parts there. It's all about the angle that it makes with two straight sides, right? Okay, we are gonna draw one more. Are you ready? Okay, here's what I want you to do. I want you to open it up all the way to a taco again. Okay? Open it up all the way to a taco. And then, if you can see, ready? Watch this. This is the only tricky part. Take one section and fold it back. Okay? So we have a taco. Take one section and fold it back. Just one of those 45s. Okay? And now I want you to draw this angle that's bigger than 90. See this angle right here? This angle right here, just the straight parts. Trace this one last one. And then we'll get really creative. And what have you drawn? Can you think about what 90 plus another 45 is? While you draw it, kind of start to do that math in your head a little bit. If you can't do it in your head, maybe on the side, you could do a little 45 plus 90. That's what we have, right? We have a 90, plus we added another 45 to it. How big is that angle you just drew?
135.
135, that's it. You drew a 135-degree angle. And that angle's called an obtuse angle. It's bigger than 90. And angles that are smaller than 90 are called they're a cute little angle. Oh, you almost want to pet them. Just like little nice cute angles. All right, so we have gotten a good start on geometry. We know that there's more to do back in the studio, but when we come back, we're going to make even another tool to use for geometry. Back in a bit.
All right, thanks for that, Scott, and always nice to have more tools to help out with geometry. I don't think I've ever seen it where it was so cute you wanted to pet it, but
you got to be careful with paper cuts. Like, that's a very precarious spot to be in right now.
Thick pieces then right there.
Oh, I hope so.
Hey, we do have phone tutors available until 5:30 this afternoon. We have Chloe, a 5th grade student from Quailwood Elementary in studio helping us out today. Right now we're going to go to the phones, and Emma, how are you today?
I'm good.
You're a 6th grade student from Reagan, correct?
Correct.
As soon as you're ready, let's hear the math problem you're working on.
Okay, so if 6x plus px equals 14x and x is not equal to 0, what is the value of p?
So this is really interesting because if we knew the value of p, we could kind of combine like terms here. So I think if we're able to get px by itself, we might have some success. So what would be your first step here?
Cancel out the 6x?
Let's do that. So what are we going to do to both sides of this equation? When you say cancel out, what are we really going to do?
Subtract
Let's do that. Subtract what?
6x.
So we're going to subtract 6x from each side of this equation. When we do that, we have 6x minus 6x, which is nothing. So we don't have to put anything out there. That's 0. But we still have p times x on one side. Now on the other side, we have 14x minus 6x. If we have 14x's and we take 6x's away from that, how many x's remain?
8x?
8x. So we know that p times x equals 8 times x. We can do something to both sides even if we don't know the value of x. And what is that?
Divide.
What are we going to divide each side of the equation by?
X.
Let's do that. So p times x divided by x is p, and 8 times x divided by x equals what?
8.
8. So it looks like p is equal to 8. Let's plug that in back into our original expression. So we're going to replace p with 8. So what does that expression look like now? We have 6x plus 8x equals 14x. Emma, is that a true statement?
Yes.
So it looks like P is equal to 8.
There
Wonderful
you go.
job, Emma.
Nicely done, Emma. Thanks for that phone call. For a great problem, you've got yourself a meal courtesy of our friends at Broken Yoke. So congratulations on that. Emma did a great problem. Chloe, I've got a question for you. Do you have any idea what you would like to do when you grow up as far as an occupation, a job, something that you would like to do?
It's a big question. Don't worry if you don't have an answer.
You could have a couple of things also in mind.
I don't know.
Don't know? Somebody said you could be anything in the world you want to be, and you can do this for the rest of your life. This is your job. Do you have any idea what it would be?
An artist.
An artist. So you like doing art? All right. Well, you know what? And you're still only in 5th grade, right? So there's many, many years to think about this. But that is exactly what students were doing, is thinking about careers when they get through with school, and that's what we did at the Career Expo last week.
It's a career exploration event geared towards middle school, high school students, even recent graduates. We've got hundreds of employees from over 100 local companies here to talk to kids about careers in their companies.
Awesome, winner!
Or make some connections with some people here tonight that might help them in their future career.
Connections make a big difference. So you get in there and volunteer, you get to know people, especially from the city of Bakersfield. So it's a great way if you want to get into the city of Bakersfield and maybe work in public works area or the parks and recreation area.
Every year the numbers get bigger and the excitement grows. Career technical education is a way for our students to figure out something that maybe they may want to pursue as their life's career. I believe career technical education helps the entire Kern County community as we provide a skilled workforce for now and in the future.
They're getting interested in things that perhaps are new industries that they've never been exposed to before. Their parents are able to give them more information and show their knowledge, their expertise, and their experience. So that's a bonding experience that's quite unique.
What is it that gets their passion? And if they can find that, if it's in the oil industry, we actually have all sorts of different skills and disciplines, whether it's IT and computers, engineering. I'm in human resources, I get to deal with people. You really just focus on what it is that they like to do, and then you can figure out what kind of industry fits.
I hope they get some good ideas about what they want to do. There's all kinds of jobs here. Just trying to recruit mainly detention deputy and deputies. It's a job that we need it. No matter what's going on, we need it.
We want to get kids thinking about their careers and kind of tie that into their education path. We think that the more focused they can be on their career path, the better they're going to perform in their education path.
And once again, a great time over at the Career Expo last week. And who knows, Chloe, you may become a world-famous artist. Come back and deliver us some art pieces that you have produced. What do you think?
Yeah.
Sound good?
Mm-hmm.
All right.
It's on tape, you
Now,
heard it.
once again, you're here to do what today?
The math.
There you go. So back over to the board, young lady. We're going to introduce you to some new notation. So, Devin, if you would be so kind as to write an exclamation point on the board.
Yes.
And then draw a number symbol, also known as a hashtag, to some students today.
Okay, I'll put that just right down here off to the side.
So, what I would like you to do is I would like you to put a 3 in front of both of those. All right. And what I'd like you to do is evaluate what 3 factorial is. And then if you guys need some help, I'm going to go over what primorial numbers are. All right? So why don't you guys start with the 3 factorial first?
Okay, so have you seen an exclamation point after a number before? No. Okay, so factorial is the result of what we call sequenced multiplication. So I'll represent it this way. We're going to create a little bit of a table here, all right? 1 factorial is equivalent to basically just 1. 2 factorial is going to be all the numbers that count up to 2 times each other. So we're going to multiply 1 times 2. And 1 times 2 equals what?
2.
Straightforward, not a trick. So what we would do then for 3 factorial is then add times 3 to this set. So 3 factorial is going to be 1 times 2 times what?
3.
So we're going to multiply all the whole number values up to 3 together. And when we do that, what do we end up with?
9.
Well, how do we get to 9?
You get 6.
Oh, you get 6, because I think you made a quick correction in your head. Yeah. So 3 factorial is equivalent to 6. Now, just a prediction, all right? How would we do 4 factorial if we were going to keep going in this pattern?
4 exclamation point.
Right, we write 4 exclamation point, and then what would we write over here?
1 times 2 times 3 times 4.
And that's how you would work out factorials as you start to multiply them up. Absolutely.
There you go. And if you know 3 factorial is 6, 4 factorial would simply be 6 times 4, and then you have the 24.
So you could also write it as 3 factorial times 4. And then 5 factorial would also be just this times the next number.
Okay.
So that's just a pattern you could work through as you maneuver your way through understanding factorials.
Now, primorial numbers are different types of numbers. Have you ever heard of those? No. See, big day for you, right? Factorials and primorials, okay? So primorial numbers is when you take a prime number and multiply it by any other prime numbers lower than itself. So 3 is a prime number, okay? So we're going to take 3, and we're going to multiply that by any primes less than 3.
So do you know what a prime number is? Or should we go over that?
Go over.
Let's go over that. Now, we know, for example, that there are some numbers, and we can find different ways to multiply. So for example, if I was to take the number, let's go with 12. How many different ways can you think of where we can multiply to get to 12?
6 times 2.
Sure, we could do 6 times 2, right? What else?
2 times 6.
You absolutely do 2 times 6. With the same set of factors, we'll just go ahead and just keep this in place. We'll just say that we're going to assume that when we say 6 times 2, we also refer to 2 times 6 because we have the same factors. And that's going to be important to remember. Is there another way we can multiply 2 different factors to get to 12?
4 times 3.
Sure. Okay. Is there another set of factors we can multiply? Even going back to a very straightforward one.
12 times 1.
12 times 1, and that's a really important one because we know that for any value, we can multiply it by 1. So itself and 1 will get us that. So we have a lot of different ways to get to 12, and some other values have at least 2 ways. However, there are some numbers where there's only one set of factors that you can multiply to get that. So for example, a number like 11. How could we multiply to get to 11?
11 times 1.
Okay. Is there any other way?
No.
No. So 11 is what's considered a prime number. So as we go back to primorials, what we do is we take every prime number from this one down and multiply them together.
So you're going to take 3. What is the next prime number less than 3?
Maybe we can work backwards, right? And think about whether numbers are prime. So what's the next lowest number before 3?
2.
2. Let's think about 2. How could we multiply to get to 2? What factors can we use?
1.
1 times what?
2.
Okay. Is there another way that we can multiply to get to 2 using just whole numbers? No. So we'll add 2 to our list. Now what about 1?
The prime number.
This is one of those age-old
Right. Yeah,
questions.
because
about
one's
one.
not prime or composite.
Right. It's neither prime nor composite, or like basically, it doesn't exist in that realm of prime or composite numbers because it's itself just one. So there are no other numbers left that we can consider. We have 3 times 2, which equals
5. Multiplication.
right.
6.
We got you. 6. So 3 primorial is equal to 6.
So this is one case where 3 factorial and 3 primorial both come out to equal 6. And later on, we're going to investigate how those are going to be a little different when we work with some other numbers. And we'll do that right after this. Today we're at Mojave Elementary, home of the Colts, and we're here to
Do the math!
And once again, we're at Mojave Elementary, home of the Colts, correct? All right, and we have some 4th and 5th grade students working on integers. We've put them in order, right? And we've added some, so now let's multiply and divide some, all right? So here's one thing that you can draw to kind of make things a little bit easier. So draw a triangle for yourselves like that. Okay, and you can put yours, so if you want to, if it's easier, because I'm kind of drawing it upside down, so you guys don't have to draw upside down also, all right? So what I'd like you to do is down at the bottom, put a negative symbol and another one over here. And then up at the top, put an addition symbol. If you get confused when multiplying and dividing numbers, integers, positive and negative numbers, if you draw something like this, it could help you out sometime, all right? So here's an example. What is 2 times 2?
It's 4.
You all know that, right? It's an easy enough problem, right? 2 times 2. Now what's negative 2 times 2?
It would be negative 4.
How do you know it's negative 4? So we have negative 2 times 2.
Wait, I think I know because you're doing 2 groups of negative.
Right, you're doing 2 groups of negative, right? So you're correct, it's going to be negative 4, okay? Now sometimes people go, I don't know, is it 4 or is it negative 4? Here's one way that you can check. The first number, negative 2, is a negative, right?
Mm-hmm.
So we're going to go like this. We're going to circle the negative. The next number is 2. Is that positive or negative?
Positive.
Positive, so circle the positive. What's the only symbol left?
A negative.
Is a negative, so we know that the answer is going to be negative 4.
Oh, that's easy.
That's easy, huh? Does that make sense?
Yeah.
Okay. So what you can do is you don't have to make big triangles, you can just make them small, right? Because you're not always going to want to erase those, right? So make another small triangle, put your symbols in it. It's always 2 negatives at the bottom and a positive at the top. So now watch how this works, all right? What's 3 times 3?
9. I mean
9, right? You do 3 plus 3, right? So 3 times 3 is 9, okay? What is negative 3 times 3?
Negative 9.
Negative 9. You've all got that?
Yeah.
Now try this. What's negative 3 times negative 3?
Negative 9.
No, 9.
Okay, so I've heard negative 9 and I heard positive 9. And I heard some like, "Ooh, I don't know which way I want to go yet. All right? So let's test this out. We have negative 3 times negative 3. Okay? The first number, is it positive or negative?
Negative.
It's negative, so I'm going to circle the negative. The next number, is it positive or negative?
Negative.
So I'm going to circle the negative. What is the only symbol left?
Positive.
Positive, so it's positive 9. All right? Do you guys see how that works? Because when you have a negative times a negative, it's always going to be positive forever and ever. If you divide numbers, it's the same thing. All right? So, choose a number between 2 and 10.
6.
6? All right, so everybody write down 6. Choose another number between 2 and 10.
4.
4. So we have 6 and we have 4. Now, choose positive or negative.
Negative.
Negative. All right. Young lady, positive or negative?
Positive.
Okay, so we're going to go like this. So we're going to go -6 times +4. Go ahead and do that real quick. -6 times +4. So first of all, think about, don't even worry about the negatives and positives. What's 6 times 4?
6 times 4 is 24.
So we know the answer is going to have a 24 in it, right? Now you have to figure out, is it going to be positive or negative? You don't want to just guess. So is it going to be positive or negative?
Negative.
How do you know it's going to be negative?
Because we have a negative and a positive. And if we do the triangle scene, and we circle the negative and positive, it will leave negative.
There you go. You've only got one negative there, right? So nicely done. Learning a little bit with multiplying and dividing positive and negative numbers with the students at Mojave Elementary. And thanks again to the students at Mojave Elementary. Had a great time working with those students. We do have Chloe, a 5th grade student from Quailwood, in studio with us right now, learning about factorial and primorial numbers. So what I'd like you to do is put 5 primorial.
Okay, so 5 primorial.
And then 5 factorial. Now, without actually calculating it out, which one do you think will have a larger value?
Which one will have a larger value? What are your thoughts about these two? Which one do you think will be larger?
They'll be the same.
You think they'll be the same? Why do you think they'll be the same?
Because with the 3, they turned out the same number.
So we know that when we're multiplying with factorials, we're multiplying every number up to a certain one, right? So if you think about what 5 factorial is, that's basically going to be 1 times 2 times 3 times 4 times 5. And we already know what 3 factorial is. We're going to multiply that by 4 and 5 together, right? Even just multiplying 4 by 5, that's going to be 20. So we know we're at least going to be doing, what, like 20 times 6? What do we remember about primorials?
That you're just multiplying the...
Are we multiplying all the numbers up to 5?
No.
Which numbers are we multiplying? What kind of numbers?
Prime.
Prime. So are all the numbers below 5 prime? Well, let's start with 5. Is 5 prime?
Yes.
Yes. What about 4?
No.
No. So we're not going to be multiplying by 4, right? So even if we were multiplying all the other numbers, we're only really doing 1 times 2 times 3 times 5. But what is 5 factorial? 1 times 2 times 3 times 4 times 5. So which one has to be larger?
This one.
5 factorial, because we're multiplying more and greater values.
There you go. Nicely done. And for just thinking about that, because it takes a little bit when you're learning something new to actually think and reason about that, why that's happening. You've got yourself a meal courtesy of our friends at Grillenberger.
Oh,
so
it's hot fire. Watch out.
on that. All right. You know what? We do have another opportunity to go visit Scott at the Boys and Girls Club and see what they're working on now.
Okay.
We are back at the Bakersfield Boys and Girls Club, and we have some more geometry to do. The blue's done, but the yellow's yet to come. Everyone gets a yellow circle. We're gonna make you one more protractor compass. I get those words mixed up sometimes. But take your circle here, right? And you know how many degrees are in the big circle. You've already written that down. Tell me again, how many in the big circle? 360, good. Fold it in half, make a taco, please. This one looks more like a taco because it's yellow.
So we don't draw it, we just...
Nah, you don't. You can put 360 on there if you want to, but you already have one on the blue one, so you know that one. And how big is the taco? 180. Remember, it's the flat side, right? The flat side is 180. So you can draw that on there if you want to, but you already know that one. This is going to be really interesting. Are you ready? We're going to go fold this in half again. And you made yourself
90.
A 90. Good. And this is where it changes. We're going to make a new one. If you fold it in half again, you'd have 45, right? Totally makes sense. But we're not going to fold it in half again. We're going to fold it twice. in two different places because we want 1, 2, 3 equal parts. Are you ready? This is going to take a little effort here. Here's what I'm going to do, okay? I'm going to take this side right here. Let's see if I can do it here for you. And fold it about 1/3 of the way over. Okay, I'll show you this side. Show you how I did that. Took this and about 1/3 of the way over. Ready? I'll show you one more time. Take this and about 1/3 of the way over. It takes a little bit of effort, okay? And then when you fold the other side over on top of it, you have a really small ice cream cone. Okay, so 2 folds, and when you open it up, you'll see that you'll have 1, 2, 3 sections that are just about equal. So I'll put mine down and I'll help you out a little bit. Yes, just like this. Nice job, Brooklyn, just like that. Violet, did you get it? You got it. Yes. Brandon, you got it. Good. How'd it go? Almost. So it was so close. It was so close. We just want to make this a little bit bigger. Okay, and your other fold is perfect. Just like that, Colleen. There you go. You got it. How we do?
I got 4.
Terry, let's see. No, we don't want 4, okay? We had 4 before, so we don't want that one. Ready? I'm gonna make the first fold and you can make the second one. I'm gonna make that first one right there, okay? And take this one and fold it back over on top of that one. All the way over. There you go, all the way over. Yep, just like that. So now you had 90 and we've divided it into 3 parts. How big is each one of those small parts? 90 divided by 3.
25.
A little bit bigger. You're so close. 30. That's it. So can you write on there somewhere 30 degrees? Because that's the smallest piece that you have. So this little tiny piece right here is 30 degrees. I don't care where you write it, but that's it, just like that. Now can you draw it, please? Draw it on your paper. Draw 30 degrees. Remember, it's just the straight parts. It's not the round part. You ready? You can just trace mine right there. Just trace the straight part. That's it, Terry. Good. The nice part about this tool is it makes everything straight, huh? Even without a ruler. It's nice and small. Should be smaller than your 45. That's it. Make it come to a point, and you got your 30. Now, I'm not going to tell you how to do this one because you're smart folks and you have the tools you need. Can you please draw a 60-degree angle? Here comes the Jeopardy music. How do we do that? 60-degree angle. How do you draw 60? Show me what you're doing. Good. That's it. Brooklyn, tell me a little bit about what you did there.
Since this one's 30, I just opened it because 30 times 2 is 60.
Wonderful. I like how you explained that too. Good. So did you hear that? If you're getting stuck, you take your 30, right, and open it up 1 time because 30 plus 30 is 60. Okay. So you got lots of angles on the front side there. Are you ready? I want you to now use your blue one and your yellow one together. Because this is the challenge. Are you ready? Flip it over to the back side of your paper so you won't get confused about all those other things. And together, you can talk out loud too because I want to hear what you're thinking. I want you to draw an angle that is 105 degrees. And you don't need to make any more folds. How will we do that? Talk out loud. How are you going to do 105 degrees?
I don't know.
Think about that. Think about it. So tell us out loud. How are you going to do that?
The 30.
Okay, the 30.
60, the 60.
Oh, the 60. 30 plus 30 is 60.
The 45.
Plus the 45.
Is 105.
105. There you go. Everyone do that. Put them together. You're going to use your yellow and your blue together. That's it. Yep. So the smallest blue one that you have and 2 of the yellow ones like the 60 you just did, right? 60 plus 45. Make that 1 smaller, okay? Because you want the smallest blue you can have. Yes, just like that. There you go. And put them right together just like that and only trace the outside because that is 105 degrees. Is 105 bigger than 90? Yes. Yes, so your angle better be bigger than 90. That's great. You know it's bigger than an L, right? It should be a little bit bigger than an L. Amazing mathematicians. Geometry. It's almost like you're smiling. I can tell you're smiling inside because you're doing geometry. It's good stuff. We have more geometry to do. If you can even imagine, I mean, there's more to do. There's more things you can do with these amazing tools, but I also know there's more questions to be answered back in the studio. So when we come back, we will use our tools exclusively to make all kinds of angles. Back to the studio.
All right, we'll check back with you guys in about 2 minutes from now because right now we have Chloe in studio and she'll have 2 minutes to solve this problem. You have the numbers 1 through 9 on the board. You may only use addition, subtraction, and multiplication. No division. Okay, so you can only add, subtract, and multiply. Those numbers have to stay in that order. And I want all of them to come out to equal 100. So, think about what you're going to do.
On the clock, and let's begin.
So we can multiply that times, you said how much?
We need to get to 100.
Okay, multiply that by 100.
Oh no, you can't add numbers in. We want this whole thing to equal 100 after we put the operations in between these values. So we can put a symbol between 1 and 2. We can put a symbol between 4 and 5. Does a symbol have to go between every value?
Correct.
Okay.
So 1 and 2 cannot become 12. It's 1, 2, 3, 4, all the way through.
Okay. So let's start off. You look like you want to start off here with these smaller values. Would you start off by adding, subtracting, or multiplying?
Add.
Let's add. Go ahead. I think the most important thing with questions like these is to just try something, see where we end up, and then adjust that based on where we end up. Okay? What would we do with 2 and 3?
Multiply.
Multiply. Now, there's something to keep in mind. Go ahead and put multiplication there. Something to keep in mind with this type of problem. If you remember order of operations, what operation are we going to end up doing first after we lay all this out together?
Adding.
Well,
No.
with order of operations, after you get rid of exponents and parentheses or grouping symbols, the first thing we would do is multiply, right? So wherever we put the multiplication symbols, that's going to come first. We're not just going to do this, then this, then this, then this. So we want to be thoughtful of where we put multiplication. Anyway, we have 3 and 4 here. We can add, subtract, multiply. We're going to add, okay? We have 4 and 5.
All right, so you're about halfway through, so we're going to let you guys keep working on that. We're going to go back out one last time to the Boys and Girls Club and see how they're doing with their geometry and Scott.
Pie? Pizza? No, these are tools for geometry. We're going to do some things with these tools, and all of my students here today have some tools here at the Boys and Girls Club, and I know that they're ready to use them one more time. So, pencils are sharpened, paper is fairly clear, you have your tools with you. Here we go. Are you ready? I want to hear how you do this. How do you make, let's see here, I'll pick a good one, 135 degrees? Teachers out there, if you ever want your classroom to be really quiet, apparently all you have to say is 135 degrees and everyone becomes completely silent.
20, right?
Tell me again?
105 plus 20.
105 plus 20 would be 125. It's so close. I like how you're thinking. Keep thinking like that.
Oh,
Keep thinking.
90 plus 45.
90 plus 45. Can someone show me the math real quick? Do the math real quick here, Brooklyn. Show me. 90 plus 45. And then just to make sure, I think that's a great idea.
Wait, no.
It's 1.3, huh? There's your 135. So with one of your tools, okay, make a 45. Which one's going to be the 45, yellow or blue?
Blue.
Blue. So you got the 45. With the other tool, the yellow one, make a 90, please. How do you make a 90? There you go. Open it up just like that. Yep. And put them together. Good for you. I like it. We're thinking there. So 90 and 45. Good, Terry. Make this a 45, okay? Whoop. There you go. There's your 45. You even wrote it down. Good job. And make that one a 90, right? And so we're going to make this, cut this right in half. Whoops. Ooh, get there. There's your 90, right? There you go. Put them together. Task number 2, and again, you're allowed to talk to each other, okay? Let us make a 210 degrees. Whoa. Talk to me. How are we going to make 210? Talk out loud. Is 210 bigger than 90? Yes. Is 210 bigger than 180? Yes, it is. So 210 is going to be bigger than your taco, right? It's going to be bigger than a taco. It's going to be bigger than a straight line. That's kind of a weird deal. Talk to me about that. How do we make an angle that's bigger than a straight line?
180 plus 30
180 plus 30
is 200.
is 210. That's it, yeah. So make your 30 with the yellow. Yeah, that's weird, huh? Maybe you want to put it up here, give yourself a little bit of room. But it is possible. And only draw the straight line part. Oh, what a wonderful, wonderful way to put it together. Yep. You got your 180 taco. Yep. And make that one really small and put it right next to it. And put the point in the middle though. Put this point right in the middle, right there. And then right up there, like that. Okay? Weird, huh? Now when you do 210, that's right, it's the big part. Good job. The big part is the 210, not the part in between, but the part that goes all the way around. In fact, if you want to, you can draw yourself a little arrow that goes from here all the way around to there and points to that one and shows that this angle is the big one and not the little one. I really like how you've done that. Yes, thank you for helping out. 180 and 30. That's it, great job. Okay, this last one that we're gonna do, and no hurry, if you're still drawing, no problem. I want you to make sure you have plenty of paper, so we're all gonna get a brand new piece, and you can use the piece of paper that you've already used, okay? You've already had as a resource, but you can use this new one on your brand new piece of paper. Are you ready? This is where I become silent. 300 degrees. Talk to me. How are we gonna do that? 300. Is it bigger than 90? Yeah. Is it bigger than 180? Yeah. It's gonna be pretty big, right? 180 plus another 90 is 270. Is it bigger than that? It's 300, right? 90 plus 90 is 180 plus 90 is 270. We gotta go to 300. Thank you for showing me the math. Tell me again what you did here. 180, that's a taco, right? Plus another 90, plus 30,
Yeah, so
and that's 300.
like this.
So now you have a plan. So this is 30, 60, 90, you need 30 more. Oh, interesting. How are we gonna do it? You can even use your tools along with someone else's tools. Put all the tools together. Terry, where's your 30? Give her a 30. Give her a 30, put it in there. That's it, put the point right there. Right there. Oh my gosh. So the only straight part you can copy right here, right? Or that you can trace is right there and right there. You hold it tight, someone else trace it. You got it. It looks like a little tiny angle, and I love how you made this angle or this line right here, right? It goes all the way around. This is a really big angle. It's not quite a 360, but it goes all the way around. So it looks like you make a little small piece or a little alligator, but what you're talking about is going all the way around. I like how you did that. Good job. Did you make it? 180. Show me your 90. Give me your 90 there with yours. Yep, good. And put it right there. We're going to put the point right here. Good. And then we're going to do 30 more. I'll hold it tight. You trace it. Just the straight part. Man, math at the Boys and Girls Club, not just math. Geometry at the Boys and Girls Club, this is fantastic. Fantastic. And now you have some tools to take home with you in case you get really bored this weekend or someone at home wants to know, how in the world do I draw angles? Now you have tools to do it. We're going to do some more math, and we know there's some more math to do back in the studio, so we'll go there now. Thanks for joining us here at the Boys and Girls Club today.
All right, thanks for that. We only have a little bit of math. Chloe got 98 with her operations over there.
Do you see how close
So
that
what we're going to
was?
do is we're going to take 9 times 8 is 72 and add all the other numbers, and that will come out to be 100. Did you have fun on today's show?
Yeah.
Well, we had fun having you on here today. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.